In this video, I will show you how to use Pointwise in order to create a database from scratch and how to discretize it. I will use a frustum geometry as an example, and the grid will consist of 5 blocks. After you launch Pointwise, you can directly start working on a new project, or you can create a new project at any point by going to File and selecting New in the drop-down menu. To construct the frustum geometry, we will start by creating a circle of radius 1 centered at the origin. So we'll go to Circle and we'll select Point, Center, and Angle. It means that to create the circle, we will select one point on the circle, its center, and the angle. So 1, 0, 0 are the coordinates of a point on the circle. The origin is the center and the angle is 360 degrees. Click Apply and OK. So this is the base of our frustum, and inside it we will create a square with sides equal to 0.5. So we go to 2-point curves and we enter the coordinates of the first vertex. We will connect it to 0, 0.50, and this one will be connected to minus 0.5, 0, 0. And you can continue creating all the edges manually. It's easy enough for this example, but I also want to show you how to use the mirroring function to do that. So we copy and we paste and we select mirror, and we'll mirror in y equal to 0. So now we have the square inside our circle. The next step is to connect the corners of the square to the circle. For that, we will select the circle and we'll split it in 4 pieces. So now we can connect the vertices of the square to the circle, and we use again 2-point curves for that. We'll just make sure that the option for snap to points is selected. Now we can select all the connectors, and we'll use 10 elements, so 11 grid points, to discretize them. And we can visualize the points by selecting points on. The next step will be to create the surface meshes or the domains. So we just select all the connectors and we click on Assemble Domains. We can use this base circle to create the second circle. The second circle will have its center at 0, 0, 2 and a radius of 0.5. To create it, we are just going to select everything we've made so far and copy and paste it. And first we are going to use translation. So the begin point is going to be the origin, and the end point will be 0, 0, 2. And we hit OK. And then we are going to scale it. The anchor will be 0, 0, 2. And the scale factor is going to be 0.5 in each direction. And we hit OK and OK again. Now we have 2 circles, and the idea is to connect the circles and the squares with each other. And to do that, we are going to use the 2-point curves again. So now we have connected the circles, and we are going to connect the squares. and we hit OK. We are going to select the connectors which we just created, and we will discretize them using 21 grid points. We can visualize them again. So now we are going to create surface meshes or domains in the vertical direction. So I'm going to disable the domains we've created so far. I'm going to select all the connectors and click on Assemble Domains. Now you can see that we created some of the vertical domains, but not all of them. So I will have to proceed by hand. So we are all set with the domains, and we can continue by creating the volumes. So I'm going to select all the surface meshes and click on Assemble Blocks. And as you can see, 5 blocks have been created. So let's see how they look like exactly. We have to unmask the blocks. I'm going to unmask everything. And this is our block 1, 2, 3, 4, and 5. The next step in the mesh generation process would be to look at the quality of the mesh. And Pointwise has very nice tools for that. Right now, all the metrics are shown in gray because we haven't selected any entities just yet. So we can go ahead and select the blocks. And now we can see that we have quite some options for what we can investigate. And if we're interested, for example, in cell skewness, we can go to maximum included angle. Here we can see that the minimum angle is 91 degrees and the maximum one is 135. You can zoom in into the cell with the maximum angle. You can also enable cutting and move the cut from the bottom to the top of the geometry. It is possible to decrease the maximum included angle by running the solve command, so we can look at it next. We are going to apply solve command to the domains laying within the circles. We will start by enabling the domains. Now we can select the domains that form the base of the frustum, and then the domains that form the top part of the geometry. The next step is to go to Grid and select Solve. Under Edge attributes, we are going to select Floating Boundary Conditions and hit Apply. So now we can go back to the Solve tab and run the solver for a couple of iterations. So already after 4 iterations, we can see how much the domains have changed. And we can continue doing that, for example, for 10 iterations in total. If you want to check how this changed the maximum included angle, you can do that directly from the solve function. And you see that it has decreased to 124.7 degrees. So we have achieved our goal and we can hit close and apply and OK. To prescribe boundary conditions, we can go to CAE and select Set Boundary Conditions. Right now we see that all the domains have the unspecified type. To change that, we click on New, and this creates a new boundary condition. We'll call it Inlet, and for the type we can select Inflow. Let's say that the inlet will be at the bottom of the geometry. So we select all the domains at the bottom and click Set. We can create another boundary condition and call it Outlet. It will be an outflow, and that will be on top of the geometry. Obviously, you can select any other available type, and when you are finished, you can simply click on Close. Finally, we can also change the appearance of the geometry. So let's select everything and make it flat. This will give the geometry a much more solid look. You can also do the same and select Shaded. In addition, you can change the colors. For example, if you want to change the color of the block in the middle, we can select it and then select the desired color. Since we picked a more solid look, we can only see it at the top and at the bottom surface. But in fact, all the surfaces of this block have become this light blue color. To save everything we have created, we go to File and select Save As. Here we can choose the location and we can give the project a name. I also want to show you how to create a CGNS file. For that, we go to File and select Export CAE. I will call it again Frustum. And I will just leave all the default settings, just hit OK. So this creates the CGNS file that we are going to use later. This concludes our tutorial on how to create a geometry from scratch in Pointwise and how to discretize it.